Hello everyone, welcome to our channel Chemistry Made Simple for NEET. This is Dr. Radha Subramaniam with you. Today we are going to learn a short trick for SN1 and SN2 reactions. You all know that this portion comes under haloalkanes and haloarenes. See, this is a very important topic with respect to organic chemistry, and you all should be very thorough about what is meant by SN1 and SN2 reaction. I am planning to teach this in two parts. First we will learn today about SN1 reaction, and in our next session I will quickly do the revisions for SN2 reactions. So before moving on with SN1 reaction, we should learn some basics about the different types of reactions and what happens in a reaction. You know, always when reactants react to give you products. Okay, so reactants are of two types. One is substrate and other is reagent. So there are two types of reactants, substrate and reagent. You might have heard about substrate and reagent in quite a few places. Okay, now when reactants react, you don't get products directly. In between you get something known as intermediate, which is a transition state. That is, before, once the reactants react to give you products, before the products are formed, in between what you get is known as intermediate. So the intermediate can be divided into three. One is, see, if C has carbon as a plus charge, we call it carbocation, and it can be an anion, that is with minus charge, and carbon can be as a free radical also. So any three are possible in the transition or intermediate state. Now we will see what is meant by a reagent. What is a reagent? It is a substance which goes and attack, that is in a chemical reaction. Reagent is a substance which goes and attack, whereas substrate is the one which is attacked by the reagent. So the reagent will go and attack the substrate. Now we can also say that substrate is the one which is attacked by the reagent. Okay, and now there are different types of solvents. So we will see what are the types of solvents. Mainly we can classify them into two types. One is polar and non-polar. See, polar can be again classified into polar protic and polar aprotic solvents. So we call it PP and PA respectively. So polar protic means it gives out H plus ions, okay, or hydrogen plus ions. And for example, we have got the most common examples are water, alcohol, then acetic acid, CH3COOH. These are all classical examples of polar protic. Now PA, that is polar aprotic. See, just the opposite of this, they don't give out H plus. For example, we have got acetone, then what is acetone? CH3CO, CH3. Suppose we substitute this carbon with sulfur, we get CH3SO, CH3, we call it dimethyl sulfoxide or DMS. See, there are different classifications among this. We are not going into detail about this. Now we were talking about SN1 reaction. Coming back to SN1 reaction, S is for substitution, okay, and N, that is nucleophilic reaction. Okay, so which type of reagent, that is a nucleophile, is involved in this reaction. So you have to remember two things. One is this is a substitution reaction, then nucleophilic reaction, and then one say that it is a first order reaction. Okay, suppose here, see, for carbon, it has got valencies here, and then X, halide ion is also there. So here this halide ion is since the halide is, if it is more electronegative than carbon, then the electron pair will be more towards this halide ion. So it gets partial negative charge and carbon gets partial positive charge. Okay, so what does this mean? That when carbon has partial positive charge, what will happen? Nucleophile will go and attack, because the nucleophile has got a negative charge and carbon has a partial positive charge. So it goes and substitutes for halogen. So X is removed from that, and in that place the nucleophile will come and attach, and these are called nucleophilic substitution reactions, or we also call them call SN1 as unimolecular nucleophilic substitution reaction. Okay, hope this much is clear to you. Now let us consider another case, like see, carbon has got 4 different groups attached to it. Okay, what are they? R, H, D and X. Let it be like that. Okay, so here the nucleophile attack will happen. Suppose in such a case where nucleophile is weak, then if the nucleophile is weak, it won't attack the carbon atom directly. And what will happen? It will attack only after halogen X moves away from this part. Okay, till that time X will not go away from here, the nucleophile. If it is weak, it won't attack the carbon, this part. Okay, so here we have got 4 bonds and we call it sp3 tetrahedral. Okay, now suppose in another case, if halogen is more electronegative than carbon, then it takes away this halogen. What will it do? It will take away a pair of electron and goes out, okay, as X minus, and carbon will get a positive charge. Okay, X will go, if it is more electronegative than carbon, it will take away a pair of electron and go out of this, and here carbon will get a positive charge. See, after X goes away, after this we get here this step, that is C with 3 groups are there, R, H and D, and we, since there are 3 bonds, we call it sp2 hybridized state, and it is triagonal planar, and we call this as carbocation. Fine. Okay, now see, after this the nucleophile can attack either from front side or from the back side. Suppose after this, if the nucleophile attacks from front side, we get a structure like this. See, this is the same, positive charge of carbon will go and nucleophile Nu plus will get attached to the right side, or back side. If it attacks from back side, means this will be the structure. Okay, and suppose what you do is, if you pass a plain polarized light through this molecule, then what happens is that one of the structure will rotate and in clockwise direction, and another one is rotating in the anti-clockwise direction. Okay, so since both will cancel each other, so we can say that optically this structure is inactive, and now we can say that SN1 will give a racemic mixture. Okay, so we get a racemic mixture as the final product. Okay, so clear about SN1 reaction. So we will take up SN2 reaction in another session. So this is very important within the view of organic chemistry. So just remember this clearly. So different cases. Okay, and we started with saying reactants react to give you products, and then we went into detail what is reagent, what is substrate, and okay, and here reagent is of 2 types. Okay, electrophile and nucleophile. So electrophile is E plus, so it is electron deficient species, whereas nucleophile is, see, it is electron rich species. Okay, that is E minus. It can donate, it is called donating pair, or it can be negative or neutral. So examples are OH minus, Cn minus, and if it is neutral, it is H2O. So we are concerned with nucleophile here, and so because SN1 is a nucleophile reaction, so we are going through this part only, and we are not concerned about electrophile in this particular case. So nucleophile is very important. Only if you understand this, nucleophile is electron rich species, and it donates electron pair, and it is negative charge, that much you remember. Then after that we went into the reaction, and first we started with 4 different groups attached to it, and then X group moved out, and instead the nucleophile, if it is attacking from front side and back side, we found out what all products are formed, and we learned about carbocation. So I hope the concept is now clear to you. Okay, so just go through this session, because I have given you a very easy way, simple way to follow the whole concept, because it is too lengthy in your textbook, and if you follow this particular session you will find it extremely easy. And since your exams are coming up very soon, so I hope you do revise all these concepts frequently, and do keep supporting us. Do share, like and subscribe to our channel Chemistry Made Simple for NEET. And I am extremely happy to note that many students are visiting our channel and going through all these concepts, and I have taken specially extra time out for you to prepare all these notes for you in a more simple way that you all will find it really easy to get the concept, because many students are telling that they are finding organic chemistry really tough. Okay, so just go through with this frequently and revise well for your exam. Wishing you all the best, and we will be winding up for today. Thanks for watching the video.